So, our second speaker is Vishal, the CEO and founder of Prowler, a Cambridge-based AI company whose mission it is to enable leaders and organizations to make better decisions by optimizing resources using AI and machine learning. Please help me in welcoming Vishal.
Thank you very much. It's fantastic to be here in Dubai. I had the good fortune a few months ago of having dinner with the CEO of the Dubai Future Foundation, and I learned about the excellent work that Dubai was doing in terms of disruptive new innovations out here. So talking about AI. So at Prowler, we like to call ourselves the decision company. At Prowler, our AI optimizes the most important aspect of any organization, and that's making decisions. Companies and organizations are essentially decision factories. There are small decisions, large decisions, some decisions that impact our lives today, and a lot of decisions that have an impact on our future. When we think about supply chains, this is the typical image that we have in our minds. Containers, ships, warehouses, distribution centers, and lots of excellent people who make it happen. And when we think about modern supply chains, what is staggering is really the extent of the speed and scale of the orchestration that needs to happen to make this whole bit work smoothly. However, in the UK, no matter what conversation you start, it somehow ends up with a B word, Brexit. So I'm just going to talk and just get it out of the way very quickly. So one of the key aspects of the Brexit crisis has been that how much of it is actually about how to continuously manage supply chains when your decision-making environment changes completely. So with new regulatory framework shifts, how do we continue to manage the products going across the borders with new checks and new border controls in place? Now, in such a scenario, the decisions that we need to make change completely because the framework changes completely, but also the same decision as before can have a completely different outcome. For example, based on the analysis, for every 2 minutes of increased time in terms of border checks at the border at Dover, which is the primary trading point between the UK and the rest of continental Europe, increases the waiting time by a factor of 3. And for every additional minute of delay, you can have an increase in the tailbacks of 16 kilometers at peak times. Right? So this is just one extreme example of the challenges that we face with supply chains every single day all over the world. So the key challenge here is that how do you orchestrate such an intricate system where every decision and every bit of information that goes in has massive consequences? There are ways to do it right. There are places where AI could help. And with no exaggeration, I can say that this represents a $1 trillion opportunity. But of course, when we talk about this opportunity, there's lots of press that goes about saying that AI will result in massive loss in supply chain jobs. People quote anywhere between 10 million to 100 million figures over the potential of AI generating unemployment globally. However, I can say very safely, now having worked for a while in improving supply chains with AI, that no jobs were lost in the creation of this AI. AI, in fact, has massive potential to fundamentally change how organizations operate by essentially acting as the next generation of tooling to improve people do their jobs better and also get the organizations to focus on their core abilities. So we have the potential to do more with more. Generally speaking, our data sucks. And so do the systems that we have built over the last few years to interpret and harness the data. Yes, we do live in a data-driven age. And over the next 2 days, you will have lots of people like me come onto the stage and talk about the transformative power of data in the way we operate. However, the truth is that a lot of the times, companies and organizations are totally not set up to take advantage of data. Data is of poor quality, it's poorly recorded, and it's sporadic. And because of that, the businesses are routinely faced with unexpected challenges and uncertainties where the systems are unable to react to this. And also, in any large organization, the decisions have massive cross-sectional aspects to it, which have impact on the infrastructure and our core IT systems. So the decisions are not really linked to a single state, but are typically a part of multiple states within an organization. To try and illustrate the point, I would like to talk about a specific use case involving pallets. So globally, there are about 5 billion pallets in circulation every single day, making them one of the key backbones of the global economy. And in the world of pallets, you have certain large companies who are called pallet pooling companies. The one we work with owns hundreds of millions of pallets. And how the food chain works is that if a manufacturer wants to ship the products to the retailers, where you and I can go and buy it, they call up the pallet company and ask them to send them a bunch of pallets. They put the product onto the pallets, it goes through a distribution points, and eventually gets to the retailers where we can buy the product. Now, in this entire cycle, once the pallet gets to the retailers, after putting the products on the shelves, take the pallets and throw them into the backyard. And of course, because the pallets in the backyard pile up and don't look very beautiful, they want to get rid of the pallets as quickly as possible. And at the same time, the pallet company wants to pick up the pallets as quickly as possible so they can put them back into the circulation so they can start generating their revenues faster. And in order to get the pallets picked up, the pallet company has a contract with the hauliers, the large trucking companies, who send the trucks to pick up the pallets. And each of these trucks have a capacity of 390 pallets. So the key decision that these companies have to make, that what is the best time to send the trucks to the retailers to pick up those pallets? So the answer is obvious. Probably, why don't you just call the retailers, ask them how many pallets you have, and then send the trucks accordingly? Well, it doesn't work like that. Because the retailers are artificially incentivized to overstate the number of pallets, because if you're a retailer and you call up the haulier and say, I have 100 pallets, the haulier is not going to show up because it's not efficient. They want 390 pallets, a full load, to be able to send the trucks. Now, obviously, because humans are very smart, they quickly learn that the magic number to state the number of pallets is 390. So you end up with an entire system where pallet numbers are routinely overstated, trucks get sent, and there's a massive inefficiency in the entire system, resulting in hundreds of millions of lost potential because of fuel burn and all those factors. So, what do you do about it? You can't apply big data or IoT to this problem. If you ask a typical IoT evangelist, they will tell you that why don't you simply put a GPS tracker on the pallet so you know exactly where they are, and once you have 390 pallets at the retailer, just send the truck and it'll go and pick it up. Now, let's try to analyze the economics of this. With more than 5 billion pallets out there globally, and $20 a pop for a GPS tracker, you're talking about capital investment of 100 billion in year one. And because more than half the pallets that come back from the field need a repair, you're talking about 50 billion investment every year after that, and that's just for the hardware alone. So, in fact, the financial, environmental, and logistics costs of putting trackers on the pallets just don't add up. You'll end up with wasteful amounts of data lakes, mountains of IoT hardware, and oceans of computing power without adding much value. So you can't IoT yourself out of the problem. You have to think of something different. So we need an approach that is both feasible and, most importantly, sustainable. Sorry, I got that right. Perfect, apologies for that. So what we need here is essentially AI for the real world, and that is designed for the way the world actually works. Traditional AI approaches for problem solving essentially rely on vast amount of data and static deterministic models, which also need vast amount of data to train. What the world really needs out here is something that can change with the way the world operates, is able to model the complex dynamics rather than just rely on big data. Because big data will never be able to model the actual dynamics of the real world. So let's look at the data that we actually had. So behind me is what we captured from this particular client that we are working with. So the actual data here is literally the failed collections and the successful collections that we got from the a client in this case, which, as you can see, that is perhaps not enough for the decision-making problem that we have, which is essentially, when do you send the trucks to pick up the pallets? To know that, we need to know the ground truth. That is the actual number of pallets at the retailers, which we don't know. What we do know, that from those green lines, that when a truck was sent, there was a successful collection. That meant there were 390 or multiples of that number of pallets. So the truck driver came, picked up the pallets, and left happy. And the red line shows that the truck driver came, found no pallets, and left being quite grumpy because there were no pallets. So these allow us to give the lower bounds and basically upper bounds of our decision making. And within that framework, what we did was use Gaussian processes to come up with a probabilistic model that essentially gave us the likelihood of the number of pallets at the retailers given the constraints. So as you can see, that as we go forward, beyond today, the number of pallets at the retailers starts to go up, which you would expect because no collections have been planned. And similarly, the other bit that you observe beyond today into the forecast of the future, that the actual uncertainty sort of goes up, or the dispersion between the likelihoods goes up, as you would expect. Now, using this framework, we proposed a collection schedule, which are the dots out there in yellow. And the goal of this collection schedule was essentially to maximize the quantity of the pallets collected while ensuring that there was a 90% successful collection rate. So essentially, it was a trade-off. So you can't optimize one way or the other because you have to really take care of what's the most optimal bit for your KPIs. And then we tested this in the field for a couple of months against the world leaders in supply chain optimization, which have been using deterministic systems for their planning. And we saw some pretty impressive numbers. So in terms of the forecast alone, we were able to improve the forecast from a MAPE of 43 to 29, which is quite dramatic. But in terms of the commercial side, we were also able to reduce the failure of failed collection by a whopping 60%. And what that really translated into value was close to 100 million kind of saving in globally for this particular client. So essentially, this entire saving was brought about with zero capital cost by really focusing on the low data regime, being able to quantify uncertainty, manage uncertainty, and have real-world gains around that. Now, for the true potential of AI to be realized in supply chains and the financial markets as a whole, we need standardization. And as a starting point, we need a standardization across data schemas across entire industries. And this will help us to unlock further amount of value, because right now we spend huge amount of effort with so-called data cleaning, because data is not inherently dirty, it's just poorly managed. And the reason for that is from the history of the tech industry. And one of the examples I like to give, which I was personally involved with, is the mobile phone industry. One of the reasons why all of us these days are able to walk around with our phones all over the world, make a call and talk and chat and send photographs to anybody else, is because in the 1980s, some European governments and companies came together to define the GSM standard. And the AI industry today reminds me of the mobile phone industry from the 1980s and the early 90s, with huge amount of fragmentation and lack of interoperability. What we need is a GSAI, which is essentially a global system of artificial intelligence. And countries like Dubai and UAE, which are known for their disruptive innovation, could play a key part in this. So the opportunity, when we work to transform the infrastructure, of which the industries that power and connect the world are built on. So there's a massive opportunity out there. But at the same time, enabling our future, driven by the promise of AI, is something that's not going to happen automatically. So success is not guaranteed. But the technology is changing and giving us extraordinary capabilities. However, we have to change with that. Thank you very much.